Japan's Godzilla F-X stealth fighter has triggered a significant response among global military powers, especially in Russia and China. The shock comes not from speculation, but from the jet's ability to slash its radar signature to near undetectable levels, forcing adversaries to rethink their air defense strategies. This leap began with the X-2 Shinshin demonstrator, tested between 2016 and 2018, which laid the groundwork for the advanced capabilities seen in the F-X today. What secret technologies underpin this next-generation warplane, and how do they set a new standard in stealth and air superiority? To answer that, it's essential to understand why stealth has always been a decisive factor in the evolution of air combat. Across decades of military aviation, stealth technology has fundamentally altered the calculus of air combat, evolving from basic radar evasion to a cornerstone of battlefield dominance. The F-117 Nighthawk, first deployed in the early 1980s, demonstrated how shaping and radar-absorbent materials could allow an aircraft to slip past even the most advanced air defenses. Early jets like the F-117 proved stealth's power, but carried small payloads and high maintenance costs. Despite these limitations, the F-117's operational record, most notably in the Gulf War, showed that the ability to strike targets without warning could cripple enemy defenses and shift the balance of power within days. The next leap arrived with the F-22 Raptor, which entered service in the 2000s. The Raptor's design integrated advanced stealth shaping, radar-absorbing coatings, and internal weapons bays, reducing its radar cross-section to levels that made detection and interception nearly impossible for adversaries. Unlike its predecessors, the F-22 combined this low observability with high maneuverability, supercruise capability, and sophisticated avionics. It could engage enemy fighters, attack ground targets, and conduct electronic warfare, all while remaining virtually unseen. This multi-role flexibility marked a new phase in air dominance, where stealth was no longer a niche advantage, but a requirement for any air force seeking superiority in contested environments. Stealth's impact on military strategy has been direct and profound. In the Gulf War, coalition forces used F-117s to dismantle Iraqi command centers and air defenses before conventional aircraft entered the fight. The result was a compressed response window for adversaries, who struggled to react to threats they could neither see nor target. This first strike advantage forced militaries worldwide to invest in counter-stealth technologies and rethink their own air defense doctrines. As stealth platforms proliferated, the focus shifted from simple radar evasion to the need for integrated network systems capable of dominating the electromagnetic spectrum. Japan's journey into the realm of advanced stealth fighters reflects this evolution. After decades of relying on foreign-built aircraft, Japan launched a strategic review of its future air defense needs. In 2009-10, the Japanese Ministry of Defense outlined the I-3 concept: informed, intelligent, instantaneous, envisioning a fighter that could process information rapidly, adapt to dynamic threats, and operate seamlessly across multiple domains. This vision guided the research that would culminate in the Godzilla F-X program, positioning Japan to develop a sixth-generation platform tailored to its unique security environment. The Godzilla F-X is not a derivative of past designs, but an ambitious response to regional threats and the demands of modern warfare. Its development signals Japan's intent to counter the expanding capabilities of China and Russia, both of which field advanced stealth fighters and maintain robust air defense networks. The F-X's design philosophy goes beyond radar evasion. It emphasizes survivability, operational flexibility, and the integration of new technologies such as artificial intelligence, electronic warfare, and advanced data fusion. Japan's F-X is designed for networked warfare, linking satellites, drones, and cyber systems in real time. This multi-domain approach allows the Godzilla F-X to function as a command node, coordinating unmanned systems, leveraging space-based intelligence, and conducting cyber operations alongside traditional air combat roles. By building a fighter that can operate within a larger, interconnected battle space, Japan aims to create an aerial system that is resilient, adaptable, and capable of overwhelming adversaries through superior information and rapid decision-making. The Godzilla F-X stands at the intersection of stealth, digital integration, and strategic autonomy. It embodies Japan's shift from a reactive defense posture to a proactive, technology-driven strategy that seeks not only to evade detection, but to dominate every aspect of the modern battle space. This approach challenges adversaries to develop new detection and countermeasure systems, raising the bar for what it means to achieve air superiority in the 21st century. At the heart of this transformation is the F-X's approach to stealth. Its design pushes the limits of radar cross-section reduction, using advanced materials and shaping to minimize its signature. But what makes the Godzilla F-X nearly invisible to even the most sophisticated radar systems? That answer lies in a closer look at the engineering behind its unseen edge. Stealth in the Godzilla F-X is not just a feature. It is a foundational principle that shapes every aspect of the aircraft's design. The focus centers on minimizing radar cross-section, or RCS, which determines how visible an object appears to radar. Achieving a low RCS involves a careful combination of aerodynamic shaping and advanced materials. The Godzilla F-X employs sharp, angular lines and carefully contoured surfaces to scatter radar waves away from their source, reducing the likelihood of detection. These design choices are reinforced by the use of composite lightweight materials, which not only decrease radar reflectivity, but also contribute to the fighter's agility and operational range. The integration of radar-absorbing materials, or RAM, is central to the F-X's stealth profile. These materials absorb incoming radar energy rather than reflecting it, further diminishing the aircraft's detectable signature. The F-X's RAM is embedded throughout the airframe, working in tandem with its shaping to ensure that radar returns remain minimal even under scrutiny from advanced detection systems. This approach builds on previous generations of stealth technology, but pushes the boundaries by addressing vulnerabilities that have persisted in other platforms. Japan's engineers have incorporated additional layers of stealth beyond traditional methods. The Godzilla F-X features serpentine air ducts, which obscure engine components from direct radar exposure. By eliminating straight-line paths for radar waves to reach and reflect off the engine's compressor blades, these ducts prevent one of the most common detection points in jet aircraft. The internal weapons bay is another key element. By housing missiles and munitions internally, the F-X avoids the radar reflections that external stores would create, maintaining its low observability even when fully armed. What sets the Godzilla F-X apart from its predecessors is its adoption of next-generation electromagnetic wave absorbers and metamaterials. These advanced materials do more than simply absorb radar energy. They manipulate electromagnetic waves, effectively bending them in ways that traditional composites cannot. By integrating both electromagnetic wave absorbers and metamaterials, Japan has taken a multi-layered approach to stealth, making the F-X exceptionally challenging to detect, track, or target. A particularly innovative feature is the plasma stealth antenna system. This experimental technology creates millisecond plasma fields that scatter hostile radar pulses, offering an additional layer of protection against detection. The system generates temporary bursts of plasma that can deflect or disrupt incoming radar waves, complicating efforts by enemy systems to maintain a lock on the aircraft. While plasma stealth remains at the cutting edge of research, its inclusion in the F-X highlights Japan's intent to remain ahead of evolving air defense technologies. The Godzilla F-X's stealth extends into the electromagnetic spectrum through its electronic warfare capabilities. The aircraft is equipped with a gallium nitride-based passive RF sensor and an active electronically scanned array radar. This combination enables the F-X to detect, classify, and track low observable targets with high precision. The electronic warfare suite can disrupt enemy sensors and communication links using targeted jamming and signal manipulation to degrade adversary effectiveness. These systems allow the F-X not only to evade detection, but also to interfere with enemy targeting and surveillance efforts, creating windows of opportunity for both itself and allied forces. The aircraft's networked architecture enhances these capabilities. The F-X can share real-time threat data across allied platforms, ensuring coordinated responses to enemy radar activity. If a hostile system manages to acquire a lock, The F-X's network can instantly alert other assets, enabling rapid countermeasures. This interconnected approach transforms the fighter from a single combat asset into a central node within a broader information and operations network. Compared to earlier stealth fighters, the Godzilla F-X represents a significant leap. The F-22 Raptor set new standards for stealth and maneuverability, but it lacks some of the multi-domain connectivity and advanced material science found in the F-X. The F-35 brought networked warfare to the forefront, but does not match the F-X's projected radar evasion or electronic warfare sophistication. The Godzilla F-X's layered stealth, advanced materials, plasma technology, and integrated electronic warfare systems collectively establish a new benchmark for survivability and operational dominance. These innovations enable the Godzilla F-X to operate where traditional fighters would be easily detected and targeted. Its ability to reduce radar, infrared, and electronic signatures ensures that adversaries must continually adapt their detection strategies. As the demands of modern warfare evolve, the F-X's engineering reflects a commitment to maintaining the initiative in contested airspace. Yet, the Godzilla F-X's stealth is only one dimension of its technological edge. The aircraft's performance and adaptability rely on what lies beneath its surface, the power plant and intelligence systems that drive its unmatched speed, range, and operational flexibility. Understanding these core technologies is essential to grasping how the F-X redefines what a sixth-generation fighter can achieve. The Godzilla F-X's capabilities are anchored by two XF-9 engines, each delivering over 20 metric tons of thrust. This power plant is not only central to the fighter's raw performance, but also to its adaptability in the air. The XF-9 incorporates adaptive cycle technology, enabling it to switch between hot mode for maximum speed and agility, and eco mode for fuel-efficient, extended patrols. This dual-mode capability gives the F-X the flexibility to dominate in both short-range engagements and long-range missions, addressing operational demands that often force trade-offs in other platforms. Managing speed and endurance is only part of the XF-9's engineering. The engine's thermal control system plays a critical role in reducing the aircraft's infrared signature, especially during supercruise, sustained supersonic flight without afterburners. By minimizing heat emissions, the F-X becomes harder to track with infrared-guided missiles, complementing its radar stealth and increasing its survivability in contested airspace. The design also benefits from the fighter's larger airframe, which allows for greater internal fuel storage and ordnance capacity compared to its predecessors, further extending its operational reach. Maneuverability is enhanced through three-dimensional thrust vector nozzles integrated into the XF-9 engines. These nozzles allow the Godzilla F-X to perform advanced aerial maneuvers, pivoting rapidly in multiple axes to outmaneuver adversaries in dogfights or evade incoming threats. The thrust vectoring capability not only improves agility, but also contributes to the aircraft's stealth by enabling flight profiles that minimize exposure to radar and missile locks. Power and agility alone are not sufficient in modern air combat. The Godzilla F-X integrates advanced artificial intelligence systems that transform how pilots interact with the battlespace. The cockpit replaces traditional metal wiring with fly-by optics data links, providing higher bandwidth and faster transmission of sensor data. This infrastructure feeds real-time information to the onboard AI, enabling it to process vast amounts of data from radar, infrared, and electronic surveillance sources. The AI continuously analyzes threats, prioritizes targets, and suggests optimal responses, giving the pilot a decisive advantage in rapidly evolving scenarios. In combat situations, the AI's role extends to automated evasive maneuvers. When the aircraft detects a missile launch or enemy lock-on, the system calculates and executes complex escape trajectories, leveraging the F-X's thrust vectoring to evade threats that would challenge even the most experienced pilots. This automation not only increases survivability, but also reduces pilot workload, allowing for greater focus on mission objectives and tactical decision-making. The F-X's AI is also designed for seamless integration into networked warfare. The aircraft serves as a command node, linking with satellites, ground stations, and allied platforms to share threat data and coordinate actions in real time. A key element of this networked approach is the integration of loyal wingman drones, unmanned aircraft that accompany the F-X on missions. These drones assist with target identification, electronic warfare, and missile defense, expanding the fighter's reach and effectiveness without increasing its exposure to risk. By embedding AI into every operational layer, the Godzilla F-X adapts to new threats and mission requirements on the fly. The system's ability to fuse data from multiple domains, air, space, and cyber, reflects a shift in how air power is projected and maintained. The result is a platform that responds dynamically to complex environments, leveraging both human expertise and machine precision. The combination of adaptive propulsion, advanced maneuverability, and intelligent systems marks a significant evolution in fighter design. The Godzilla F-X is not just a product of incremental upgrades, but a comprehensive rethinking of what a modern combat aircraft must achieve. Its interconnected systems, high thrust, and AI-driven capabilities position it as a central asset in Japan's defense strategy. As these technologies come together, their impact extends beyond the technical realm. The Godzilla F-X's arrival signals a strategic recalibration in the Asia-Pacific, a region where military balance and geopolitical interests are increasingly intertwined. Russia and China have watched Japan's introduction of the Godzilla F-X with heightened concern, recognizing the fighter's potential to disrupt established air power dynamics in the region. The F-X is engineered to meet the realities of contested airspace. Its internal weapons bays are designed to host hypersonic missiles capable of Mach 5+ strikes, giving Japan the means to deliver rapid, hard-to-intercept attacks deep into adversary territory. At the same time, the fighter's electronic warfare suite allows it to blind enemy radar and communications by instantaneously sharing threat data across allied networks, negating the effectiveness of coordinated responses. For both Russia and China, these capabilities compress decision windows, leaving less time to react and increasing the risk of being outmaneuvered or surprised. The immediate strategic impact is clear. China's frequent air and naval activities near Japanese territory, including live-fire missile drills in proximity to Taiwan, have already pushed Japan to modernize its air force. The Godzilla F-X arrives as a direct answer to the fifth-generation aircraft fielded by China and Russia, such as the J-20 and Su-57. While these aircraft have advanced stealth and networking features, Japan's sixth-generation approach with the F-X introduces new variables: hypersonic strike, advanced electronic warfare, and seamless integration with unmanned systems and satellite feeds. This multi-domain capability means the F-X functions not just as a fighter, but as a command node, coordinating drone swarms, cyber assets, and real-time intelligence to extend its operational reach and complicate adversary planning. Japan's pursuit of the Godzilla F-X is also a response to the evolving limits of its post-war defense policy. Article 9 of the Japanese Constitution has long constrained the nation's military activities, restricting them to self-defense. However, the regional security environment has shifted. The development of the F-X signals a nuanced evolution. Japan is reinforcing deterrence and readiness while remaining within the letter of its constitutional commitments. The fighter's advanced capabilities serve not only to defend national airspace, but to deter aggression by signaling that any incursion will meet a technologically sophisticated, coordinated response. Alliances play a critical role in amplifying the F-X's strategic value. Japan's defense partnerships, especially with the United States, provide the technological and operational backbone for rapid integration of new capabilities. The Godzilla F-X program is not developed in isolation. It is part of a broader network of collaboration. Notably, Japan's joint engine demonstration with Rolls-Royce and Italy's Avio, launched in 2024, highlights a commitment to shared sixth-generation technology with the UK and Italy, partners in the Team Tempest initiative. These collaborations extend deterrence and operational flexibility, linking Euro-Atlantic and Indo-Pacific security architectures, and reinforcing Japan's position as a reliable ally within a collective defense framework. For China and Russia, The arrival of the Godzilla F-X introduces new challenges that require substantial investment in counter-stealth and electronic warfare technologies. Both nations have accelerated efforts to field over-the-horizon and low-frequency radar systems, seeking to detect and target stealth aircraft more effectively. However, these systems face limitations in precision tracking, especially against platforms as advanced as the F-X. The resources required to develop and deploy credible countermeasures stretch defense budgets and may force difficult trade-offs in other strategic areas. The result is a shifting regional balance, where Japan's technological advantage compels adversaries to adapt or risk falling behind. The Godzilla F-X also marks a departure from Japan's historic reliance on imported defense solutions. By investing in homegrown technology and fostering international partnerships, Japan demonstrates an intent to maintain autonomy in its defense posture. The fighter's integration with cyber, satellite, and unmanned systems further reduces dependency on any single domain or ally, allowing Japan to respond flexibly to a range of scenarios, including those involving contested trade routes or potential flashpoints such as Taiwan. The implications are significant. The Godzilla F-X is not simply a new aircraft. It is a strategic instrument that forces adversaries to reconsider their assumptions about air superiority and regional power projection. Its presence signals that Japan is prepared to defend its interest with the most advanced tools available, reshaping the calculus for any nation contemplating escalation in the Asia-Pacific. As the Godzilla F-X enters service, its influence will extend beyond technical innovation. The fighter stands as a marker of Japan's evolving approach to security and its willingness to take a leading role in shaping the future of aerial combat. This evolution sets the stage for a new era in regional and global defense, raising the question of how the balance of power will shift as nations respond to Japan's leap forward. As the Godzilla F-X enters service, one high-impact element stands out: its AI-driven coordination with loyal wingmen drones. These unmanned aircraft support the fighter by extending its operational range, assisting with munitions deployment and intercepting threats, all while sharing real-time data. Combined with cyber warfare capabilities, the F-X forms the core of an interconnected combat system designed for rapid response and persistent situational awareness. If you found this deep dive useful, hit like, subscribe for more tech defense analysis, and leave a comment on which F-X feature you think shapes the future of air combat.